Hey guys, welcome back to the next tutorial in the series. I don't know why this is all messed up. This one is going to cover. Well, first off, let's cover. Let's see where we're at. Basically, at the end of last tutorial, we had basic sprites and text rendering using the sprite batch to draw both the sprite here that we had, the DDS texture file, which stands for Direct Draw Surface, and the sprite font we made using the Make Sprite Font tool. So, if you haven't watched that video, please do, because that prefaces a lot of this. Now, this tutorial we're going to cover wrapping sort of XNA kind of functionality into a class for both text rendering and for sprites, so that we can draw them using set position, scale, alpha, color, you name it. Now, to do that, let's start off with a good class structure. So we know that both the text and sprites should generally have some common things. Like, let's look at the sprite batch draw. And as you notice, it has at the most basically the texture, position, source rectangle, color, rotation, origin, scale, sprite effects, and layer depth. Now, the sprite font generally has similar things. It has the sprite batch, but it has the text. It has a position, color, rotation, origin, scale, sprite effects, and layer depth. So as you can see, the position, color, rotation, origin, scale, sprite effects, and layer depth are all common to both text and sprites. So what we can do is we can make basically an interface that they both classes need to implement, so that we can store them in collections easier and loop through and not have to worry. So what we can do is we can make, you don't have to do this, but generally I like doing it like this. So we're going to make a iElement 2D pragma once class iElement 2D, and what we're going to do is all we're going to create here is a virtual destructor that does nothing. So basically we're kind of saying this is an interface. So now we're going to make our virtual methods. Now first we have to include some things, because what we're going to want is we're going to want to have these position, origin, scale, all those things. So we're going to have to include simple math that will have our vectors, twos, and other handy functions. So to start, let's start with well, I'll just do it. We know they're all going to be virtual, so let's start with getters. So for the getters, what we're going to return are virtual const. Let's do position first. So, well, first we're going to do this using namespace DirectX simple math. So that way we don't have to put this before every vector 2. So it's going to be a reference called get position, and it's also going to be const, but it's also going to equal 0. So these are what are called pure virtual functions, which I mentioned before in the first tutorial. This basically means that whatever inherits from iElement 2D, our interface, it must override these, or else the compiler will throw an error. Now, this you may think is weird why we have const after and before. Basically what this means is that what it returns is a non-mutable object, and this const at this end means that it can't be changed. You can't modify the value within, so nothing can be modified within it. So basically it's just const correctness, saying that all this does is return the value. We can't modify the reference that's returned. So same thing, we're going to do reference get origin, and we're just going to go through and sort of get a bunch of these. We're going to get a color reference, so get tint. I'm calling it tint because it's not really color, it's sort of like a tint that's applied when you draw. So that's, I think, all the vectors we need, and the color. So now we can start doing some get alpha as well. Actually, well, I like doing the capital one, so I'm just going to include also the DXUtil, I think, has it, right? Does that have Windows? Nah, it doesn't. Can't use that, because otherwise we'd have to import the Windows header. So we'll just use regular floats. It's just a type define. I like the all capitals because it's like Win32 programming. But so get tint, get alpha. What else do you think we need? Oh, rotation, of course. So what else? Origin, scale. Actually, technically, wait. We have scale as a vector, but can it be passed in as a float? Yeah, it can be passed in as a float. Let's do it as a float. Actually, no. Let's keep it as a vector. Let's keep it as a vector because then you can do non-uniform scaling. Passing in as a float is saying it's basically uniform in both directions, but this gives you more control. Just pass in 1, 1 if you want it to be, you know, the same rate. That's it for our getters for now. How about setters? Set position const vector2 reference position equals 0. So virtual void set origin const 2 reference origin, and you're just going to go through and create all these. And scale. Cool. And tint or color. And virtual void set alpha const float alpha 0. There's not necessarily a need to pass by reference here. We can just pass by value. It's not a problem. Okay, so now that we have our setters and getters, we also have the virtual void draw, which, by the way, reminds me we're going to also have to include Sprite Batch. And what this will take is a DirectX Sprite Batch pointer, Sprite Batch. So we have draw, and that's about it. That's all we need right now, I think. So, okay. So now let's create our Sprite class. Sprite. I'm going to include element 2D. What we're going to do is extend publicly the I element 2D. Okay. Now this might be pretty freaky what I'm about to do. Now what you're going to have to do is you're going to have to actually type virtual void. These are not virtual, like set and override them yourself. But since I have what's called Visual Assist X, what I can do is I can right click here, implement virtual methods, and it'll bring up this. And see all these, any that are selected when I hit OK, this may look freaky, get ready. It auto-generated the stubs and the implementations here. So that's a very quick way to do it. It costs $100, but if you tell them that you work at like some sort of company or like or actually no, if you tell them that you work at a school or are a student at a school, then they'll give you a discount. So that's how I got my discount. So these are getters, setters, and the render. Okay. Oh, there's one more function that we forgot to add to. Clearly both the font and the text, the sprite have in common is they need to load some sort of value. As you can see, they both load using a device. So here we create a sprite font object using the device and the sprite font. Here we create the texture using the device and a string path, and then storing it in the texture. So what we can do is actually go back into iElement2D and create one more virtual function called load function and virtual void load. And what it'll take in is it takes in I D through D11 device pointer and a basically a const wchar sheet wide character string file. So now if I go back in here, there's going to be one more function that I didn't implement, which is going to be this. So here it is. Load. And there it is. Okay. So I'm going to move this up below there. So it's because we're going to be doing a lot in this. Okay. So what does a sprite need that text doesn't and not all element 2Ds do? It needs basically a shader resource view and a resource. Now the shader resource view holds basically the actual image. The resource holds a pointer to, like a generic pointer to the actual resource itself, which using that you can get information about like the width and height. So what we're going to do is we're going to give in the protected properties, we're going to give it a resource pointer, a shader resource view, the texture, and there we go, we have these two things. But then we also need a position, origin, scale, tint, alpha, rotation. Now you could make them protected in here and have this as kind of like an abstract class. Would that be better? Do you want to do that? I think that might be better. Let's do that. So protected as part of the Element 2D interface. Technically, interfaces are only ever supposed to have functions. That's why I think we shouldn't really do that. You could make this an abstract class or inherit into from like a base class, but yeah, let's just type these out ourselves. So again, the first thing we're going to have is a vector2 for position, a vector2 for the origin, a vector2 for the scale, a color for the tint, what else are we going to have? A float for the alpha, float for the rotation, tint alpha rotation. That's it. That's all we need. Okay, so in here, our sprite constructor should take basically, we'll have a basic constructor. So we have the empty one, we'll just keep that. Then we're gonna have one that takes that takes in a position. So we set the initial position. So what we're just going to do is we're going to set position equal to position. We're going to set our basic alpha to 1 so that we can actually see our thing. We're going to set our rotation to 0. We're going to set our scale to vector2 1 1. So we're just going to have we're not going to have any upscale or downscale. We're going to set our tint. We're going to actually set to DirectX colors white, but we can't just set it to that. We need to go .v, so we need to get the XM vector stored in this, because this is basically a redefine of XM vector. Because if we did this, it would throw an error. So, and this is no change basically. If the color is white, it'll be no change. And what else do we need to set? Nothing else in here. So now let's tackle load. Now we already wrote the basic load code right here. So we could generally just copy this and then edit it a bit. So paste that in. Of course, HR is undefined because we don't have, no, we have util, it's declared in here. No. So what we're going to have to do is put, let's put it in here, include dx util. Okay, so but the problem it's having is it doesn't know that where this exists. So remember that is included in DDS texture loader, so direct draw surface texture loader. So now it knows, but it doesn't have the device because that's not what we called our parameter coming in. So now it has no errors, but we shouldn't be passing in just this. We should actually pass in file. And for this null pointer, instead of passing in a null pointer, we're going to actually pass in our resource. So now we have stored, once this runs, we have our texture and our image, and we have our resource, handle to our resource, basically. So what we're going to do is we actually want, in order to calculate origin, the center of the object, we need to get some information about our texture's width and height. Now, in order to do that, we need to create some sort of utility function. So the way we're going to do that is we're going to go into DirectX util. We're going to create a new namespace called utility. In here, we're just going to create a void called get texture dimensions, and what it's going to take is a D3D resource and a unsigned int pointer width, unsigned int pointer height, and we're going to implement this. Cool. Okay, it doesn't want to implement, so it doesn't want auto. So we'll just go utility get texture dimension. Void. And so in here, let me explain the resource. What's stored in the resource could be either a 1D texture, a 2D texture, a 3D texture, a 4D texture. So what we want to do is we want to first get what type it is. So to do that, you do D3D11 resource dimension, and then you call resource get type, I believe it is. Yeah, then you pass in the dimension. So now we have inside this dimension struct what type it is. So what we're going to do is we're going to switch on that, and then in case it's D3D11 dimension texture 2D, we're going to do something. So in here, what we're going to do is we're going to go and auto texture, and what we're going to do is we're going to reinterpret cast as a I D3D texture 2D pointer the resource. So now we have basically a texture, and it doesn't care because of auto. It'll just ignore any sort of compiler error. And then what we'll do is we'll go create a D3D11 texture 2D description. So description. So this is going to hold our information about our texture. So get description. And then if width, we're going to store in width the description dot width. If height, we're going to store in there the description dot height. So this is the width of texture in pixels. That's in pixels. So 64 by 64. You know, that's what you're getting right here. So there you go. Now, what we also want to do though is have some sort of default case. So what we're going to default to is just setting. So let me just copy this. We're just going to set it to 0 in the case that it's not this type of texture. Now what you could do is you could also add cases for texture 1D and texture 3D, but right now we really only care about texture 2Ds. So now that that's done, what we can do is right under here we can go, and what we'll do is we'll add 2 more members here. We're going to add a uint for width and a uint unsigned integer for height. And right in here we're going to call utility get texture dimensions, we're going to pass in our resource that was created right here, and we're going to pass in our width and height. So once those are set up, we're going to set our origin. So we're going to set origin equal to vector2 width divided by 2.0 and height divided by 2.0f. So basically our origin is going to be the center of our texture, because if any of you have used XNA before, when you draw based on the origin, it will shift the texture. Instead of drawing it at the top left corner, it draws it at whatever your origin is. So if you choose the center, it'll also change the rotation point. So now the rotation point, when we rotate our texture, it's going to rotate around the center point at the origin. So you want your origin basically always to be the center of your texture. Okay, so your origin's set up now. But remember, you have to call load, so you basically can't even use the sprite until load's called. So now let's just quickly implement all these. So return position, return origin, return scale, tint, alpha, rotation, set position, set origin. So these are methods, these are setters, so if you want to change them, change something, you know, during runtime, you can call these. But generally when you set up your sprite, it's already going to have these values initialized. That should have been a color. We messed that up. Go in here, change that to a color. And back in here, change this to color. Sorry about that. We messed that up. So there it goes. And alpha equals alpha. Rotation equals rotation. Okay, so now we get a set of draw. Now, let's remember before, the draw we had in here in our main was a little bit different. It had far less. All it did was take our texture and our vector in a vector2 for our position. But now what we're going to do is we're going to do the full draw. So we're going to have our texture. We're going to have our position. Oh, there's one more thing that we forgot. So this full version of the draw also takes in a source rectangle. So what we're going to have to do is also create one more thing. We're going to have to create a rect called source rect. And in our in the load, right here after our origin, now that we have our width and height, all we have to do is basically set the source rectangle. The top. Okay, let me explain. This is a little bit different than the way you know, C# wraps this. C++, the rect is left is basically will be 0. That's the top left corner. The source rectangle at top will also be 0, because these two together make the point that's the top left corner. And then the bottom will be the height, and the source rect right will be your width, because these together make the bottom right corner. So we want to display our entire texture. Now if you were to like cut these in half, it will only display part of your texture. Okay, so what we're going to do now is pass in our source rect, the reference to that. We're going to pass in our tint. We're going to pass in, actually, we're doing this in the correct order. What one are we want to use? We want to use the one that has the position, source rectangle, color, rotation, origin, and this one. Okay, so we're gonna have rotation. We're gonna have origin. We're gonna have scale. We're going to pass in DirectX, Sprite effects none. Now you could change this draw to, you could add another version into Element 2D that takes in a sprite effect. So you could change, let's say you want to flip the sprite, but right now we're not really worrying about that, and we're not really doing any depth buffering, Z buffering stuff, so depth can just be 0. Okay, so there we go. Our sprite should be done. Now again, for good memory management, we have to safe release our texture and our resource. So there we go. So let's try and instead of drawing using this, now I'll keep the font there, but let's get rid of the draw to sprites, and let's get rid of the importing of the texture for rendering. And what we're going to do is instead, and we can even get rid of this texture value, we're just going to create a sprite pointer, sprite. I'm going to add the include, of course, so we're going to include the sprite. We don't have to safe release that anymore, but we should safe delete our sprite. And what we'll do is we'll set sprite equal to new sprite. Oh, no. And remember, this took in a position, so simple math, vector 2, let's draw it at 100 by 100. And all we have to do is we should just, forgot a big step. Remember, you always have to load, call load. So sprite load, you pass in the device and then your string. So ours was, I called mine test.directDrawSurface, and draw sprite. So sprite draw, and all you have to pass in is sprite batch dot get, because it's a smart pointer, so you have to call get to get the actual pointer. And let's see if this runs. Now it should just draw our texture again. Oh, we got a problem. Load unresolved external symbol. So element 2D load. Oh, I gotta set that to be pure virtual. Sorry about that. There you go. So it's rendering. So now you have your own sprite class. So you can do interesting things with that, like move around. But now it's encapsulated. So we could set the position at runtime. So let's do a little if get async key state. Let's just say if you hit the D key, what we're going to do is we're going to call sprite set position to DirectX simple math vector 2 300 by 300. So what you should see is the sprite move to, when you press the D key, to 300 by 300. There you go. See, it just blinked. So all the methods work. There you go. So it's a wrapped sprite class. So in the next tutorial, I'm going to go over doing the text. You could probably figure out yourself right now. Actually, it's not that much difficult. It's not much of a difference. But yeah. And in the coming tutorials, I'll introduce direct input and we'll create an input class to wrap direct input so that we can get actual game input with the mouse and the keyboard. That's more high performance than just the Windows Win32 stuff. And what else will we be doing? We'll be doing we'll create an element manager that can just manage your sprites using unique pointers and maps. And then maybe even create a text box like editor for text input. And that's about it. Well, for the next few tutorials. Of course, we're going to start 3D soon as well. So, thanks for watching. Hope you enjoyed the tutorial.